Hi, my name is Carly, and today we are going to be doing the Interactive Advanced Concept Presentation 8. And today we will be doing instant ice and talking about nucleation point. So I'm going to go over our materials that we have. My water is actually still in the freezer, so I'm going to get that out. And we have a cup of ice, and then we also have a cup with just one ice cube that I will use. So the steps that we are going to be doing today: first, we'll start off with one cold water bottle, and we will apply force to it to try and instantly freeze the ice that is in it. For the second experiment, we will pour the cold water over top of the ice and try to form ice crystals. And then for the third one, we will have a cup of the cold water and we will put the ice cube in it and try to form ice crystals that way. So we will kind of get into the chemistry and explanation of it after we do this. All of my water bottles are sealed, purified water. That's important in this experiment. And they've also been in the fridge for a little over 2 hours. We will pull those out very carefully. Okay, so I have my 3 cold water bottles here. I'm going to set these ones off to the side, and this one we will try to do the instant ice with. I'm actually going to use the countertop here instead of the stove. And we're just going to apply force. It worked a little bit. And as you can see, there is some ice crystals forming in our water bottle here. Yeah, here you go. You can see here a little bit that ice has formed. So what we are doing is applying what's called, we term it a nucleus, or a nucleation point is when you're talking about phase change. It's the point in which either a liquid goes to ice or a liquid goes to vapor. It's a phase change. In this case, we're doing liquid to ice. But what we term as the nucleus is what is making this phase change happen. So in this first experiment, it was the force that we applied. So in the super cold water, which is just cooling water past its freezing point, but it's not actually turning into a solid. The H2O molecules are stable on their own until some sort of nucleus is present that causes them to form to one another. So using the force, we are changing the molecules. They were stable on their own just in the water bottle. When we applied the force, then it moves those molecules around, and then they can form together and come together to form ice. So for the second one, we will pour the cold water, this is a different bottle, over top of this ice, and we will see if we get ice crystals formed. I can see it very slightly. I'll keep pouring it and see. So I don't think you're going to be able to tell, but this ice cube here actually formed some, it's kind of hard to see, formed some on top right here. So this was flat. There you can kind of see this was flat before, and this is kind of slushy, which is what we want. It's kind of like a snow cone material, I guess you could say, or consistency. So that was the small amount of ice crystal formed. The rest of it is just kind of cold water and ice. Give me 1 second. And then for my other one, my ice cube's kind of melting, so I'm gonna get a new ice cube. Okay, so we have an ice cube, And we are going to take our other cold water, slowly pour it into our beaker. Okay, and then we are going to drop our ice cube into here and see if it freezes. So I'm not seeing it freeze in this one. I think these were all in different areas of the fridge as well. So I think that the temperature of the water could be a little bit different. So I'm gonna pour this out and I'm gonna try it with another one. So let's try with this water. So I have another ice cube and I just poured some more water into my beaker here, and let's see if this... maybe the slightest bit. It's kind of hard to see. I don't know if you can see it. Definitely not a lot, if barely any. So I would say, yeah, it's probably definitely the water temperature. Probably the water could have cooled for a little bit longer, and we would have seen more of a result, but the first one worked well, the second one worked okay, and the third one worked maybe a little bit. But I kind of went over the chemistry behind what we're doing, but I'll just go over it again. So supercooling the water is putting it at a cold temperature. It's going below its freezing point, but it's not turning into a solid. And then we need some sort of nucleus in order to create the nucleation point of the phase change. In this case, it would be water to ice. So in our first one, we applied the force to the cold water and caused those H2O molecules to bump into one another and form ice. In our second experiment, the ice itself already in there is our nucleus. When you pour the water over top of it, then you see that the water will instantly start to form new ice crystals. And then in the third one, at least what was supposed to happen, was that we have the really cold water, and then our nucleus would be our ice cube, and we would put it in, and then ice crystals would form. So I wouldn't say that it failed, but it probably could have been better if we would have probably cooled the water a little bit. Also, it's warm in here in my environment, so the ice cubes also started to melt quite quickly. So even just coming out of the freezer and setting them on the counter for a second caused them to melt a little bit. But this was the Interactive Advanced Concept Presentation 8, and thank you for watching.